Tucker, thank you for joining me.
Pleasure, Anthony. Thank you for having me.
I wanted to get you on this podcast for a while, as I think you're probably one of the foremost experts in this space in the world. So excited to chat about all that you've learned over the last 10 plus years.
Yeah, it's been a funny journey. I never really thought I'd wind up being expert in any sort of nutrition topic. It was frankly never something that I had any interest in until I had to.
Yeah. So yeah, let's dive into that. I mean, you don't have a background in nutritional science, but I think you are more educated than 99% of PhDs in this space. So I'm just curious, you said that you needed to sort of figure out your own path. What was the cause of that, and sort of what brought you down this journey?
Well, I was in my late 30s, and I found myself on a conference call at work, unable to talk, and about a third of my vision had gone away. So I managed to excuse myself from the call and went to my boss, and I was able to get out. I can't talk. And luckily, one of the fellows who was working for me at the time had been an emergency medical technician, and he diagnosed me as having a stroke, threw me in his car, and drove me to the local stroke ward, which, due to his background, he knew where it was. And spent the next 4 days there. It was a teaching school, so I was being poked at by all these medical students, and they diagnosed me as having had a transient ischemic attack, which is, kind of the typical form of stroke. But it was odd because I didn't have any symptoms of it. And typically when you have a TIA, you have this, immediate loss of function, and then you start getting better. Whereas I had a loss of function that lasted for 5-6 hours. So, I wound up spending a lot of time. At the time, I was the chief technology officer for a major Wall Street hedge fund. And I was largely self-taught in technology. I, started with a startup hedge fund and basically taught myself how to do all the technology stuff that needed to be done. I taught myself how to program, and obviously was good enough at it so that this other company had hired me and given me responsibility for all their technology systems. And ultimately I wound up running their risk management systems with a team of comp sci people working for me. So I, started doing research, trying to figure out what was going on with me, and working with the doctor who was the professor of neurology at this teaching hospital. And finally, I got him to change his diagnosis. And he said to me, from stroke to migraine. And he said to me, this is the first time I've ever changed a diagnosis because of information that a patient's given me. So I said, okay, so this is something else where I can learn, how to do the research and come to valid conclusions. Now it was kind of, practically speaking, the difference between a stroke and a migraine didn't mean a heck of a lot, except that if you have had a stroke, it means that your risk of having another stroke is like 4 to 7% per year. And being in my, I was 38 when this happened. That meant that my risk of having a bad outcome for the rest of my life was extremely high. Whereas realizing that it wasn't a stroke and it was just a migraine basically meant that it was a inconvenience, albeit a lifelong one. So, then 2 years later, I came down with acute diverticulitis, which meant a perforated colon, and another trip to the hospital, another 4-day stay, managed to avoid an immediate emergent surgery thanks to having a very good surgeon, and but wound up having to do that 6 months later. And again, I started doing, research into what was causing this. And, so now I'm living with these two conditions, that are both even the surgery didn't cure it, although they told me it would. So now I'm living with these two conditions that have a pretty significant impact. You know, and I'm looking at myself in the mirror thinking, wow, dude, you're getting old. This is horrible. This is, you know, you're not going to make it to your 90s like you thought you were going to. So then I came across, somebody sent me an article one day and I started reading it. And this fellow who at the time was a who was a PhD, Stefan Guillenet, did this amazing series of posts about dental problems. And I'd always had, you know, growing up, lots of dental issues. And I assumed it was genetic because I had lots of cavities. I had 8 teeth that had to be pulled, including my 4 wisdom teeth. And Stefan made the case that it was all entirely 100% related to diet and that genes had virtually no impact on it. And that absolutely blew my mind. The idea that all that suffering I'd been going through in the dentist chair as a kid was optional. Now, at this point, I had finally listened to my dentist when I was 18 or so and stopped eating sugar, which stopped all the calories. So I was really or stopped all the cavities, I should say. So I was open to the idea that diet could have a big impact on it because I'd already basically resolved that situation. And so, you know, following Stefan's lead, you know, again, going through, doing all the research, reading all the papers that he linked to. After several months, I decided to do something that nobody else really does, which is cut seed oils out of my diet.
What were the biggest things that pulled you to that conclusion?
He had a bunch of posts linking seed oils to cancer, particularly skin cancer and sun sensitivity. And there was some evidence, you know, and it was just curiosity. I was down in, his 2 big issues at the time were carb consumption generally and wheat, which I thought he was nuts about, and seed oils. So one day, you know, I thought the idea that, anyway, so one day I'm down in the cafeteria at work and I get to the end of the salad bar line and I look at all these squeeze bottles of salad dressings and I think to myself, you know, these got to be the nastiest, cheapest oils that are available to man to make it into this lousy cafeteria. And so I just said, you know, what happens if I stop eating these things? And so I did right there. And I put some vinegar and some salt and pepper on my salad. And at that point, pursuant to the acute diverticulitis, I had been suffering from irritable bowel syndrome or inflammatory bowel disease, whatever you want to call it, for 16 years. The main symptom of which was chronic diarrhea, which was rather unpleasant. So if I traveled anywhere, I had to carry a roll of toilet paper with me in a backpack just in case. And after I stopped eating seed oils, that resolved in 2 days.
2 days.
2 days.
Did this accompany any sort of reduction in wheat or carbs or anything else, or was this the only change that you made?
Well, that was the other interesting thing. You know, what's interesting is I'd been avoiding added sugar for, you know, I was 38, so for 20 years at that point. Or no, I'm sorry, I was 42 when I fixed my diet. So, you know, 20 odd years at that point. I had still put on weight. I ate what I thought was a healthy diet, you know, because if you don't eat much added sugar, you know, you don't eat a lot of junk food. So that kind of improves things. But I still was 20 pounds overweight, call it, and obviously quite sick. And I tried going on a low carb diet to lose the weight, and I'd never been able to get over the carbohydrate cravings. So it had never worked for me. When I stopped eating seed oils, I forgot to eat carbohydrates for the next week. Just literally never occurred to me to eat them. And then at the end of the following week, I went down to the cafeteria and I got a roast beef sandwich on whole wheat bread and ate that and felt absolutely horrible. And all of a sudden I said to myself, wait a minute, could I be one of these people Stefan's been talking about who's got a wheat problem? So then I went into trial and error mode, and I intentionally didn't eat any wheat for the following week. And then, you know, the next Friday I had the guys in the office ordered a pizza. So I had a couple slices of pizza, and it put me on the couch in my office for a couple hours to recover. So lo and behold, all of a sudden I discover I'm one of these people who's got these problems. And I start going into, you know, trial and error mode. I mean, I'm kind of a self-taught process engineer. So, you know, and very good at debugging these complicated systems that I built and bought. And so I was like, okay, well, let's figure out, you know, why am I having these symptoms? Why, you know, what's going on here? So I started doing a lot of reading and doing a lot of self-experimentation, you know, adding, removing. It was a grim day, the day I had to give my Scotch collection to a friend, because I realized that basically, you know, I was super gluten sensitive. That was the cause of a lot of the stroke symptoms. And, you know, I had to give my Scotch collection to a friend because I realized I was never going to be able to drink them again.
Even a little bit of Scotch would flare you up.
Yeah, and that's interesting because, you know, Scotch is considered to be safe for celiacs. Celiacs are people who have a, you know, extreme wheat sensitivity, but typically they give me a ripping headache, even if I have just like a glass. So there's something neurological going on, and I have no idea what it is, but, you know, the fact that it's so consistent. Beer, another, you know, I was a big microbrewery fan. The last time I had a 6-pack of beer, I wound up, which was probably 3 years ago, I had my stepbrother over and had bought some beer for him, and wound up, you know, drinking a 6-pack over the course of the weekend after he left, just to see what happened. I wound up vomiting blood into the toilet. That was not good.
So you obviously have this sensitivity. You talked about having remarkable positive effects after cutting off the seed oils. Do you notice that they give you different symptoms and they're independent of each other in that way, or are they?
Yes, they're independent of each other. I can make my symptoms come back if I eat different things. I mean, you know, the combination, probably the single worst thing for me is deep fried buffalo wings, because it's got wheat, it's got seed oils, and it's got hot sauce. I mean, hot sauce, I love hot sauce, but, you know, let's be honest about that, right? Capsaicin, the thing that makes things hot, is a biotoxin. I mean, that's what makes pepper spray. So those are the 3 things that really give me a bad reaction. And if, God forbid, I eat that together, it's just catastrophic.
Maybe you can add in some dressing on the side that's full of soybean oil too, just to top it off.
Oh yeah. Yeah. I messed up once. The last time I had that combination at my favorite bar with a bunch of my ski buddies, and, you know, the next morning I was driving to work and I started sweating, and I had to pull over, you know, and find a bathroom immediately. It was just brutal.
Yeah.
Without going into too much detail. But what I found out was, you know, so I stopped eating seed oils. I stopped eating wheat pretty much by accident, and then discovered, you know, that I had an issue with it. And all of my health problems went away. I lost all the extra weight that I had. All the people I worked with started, you know, coming up to me and saying, wow, you look great. You've lost so much weight. What are you doing differently? I discovered that my propensity to sunburn went away in weeks. And we should probably get into that whole topic, because that was rather mind-boggling. And, you know, I had autoimmune issues my whole life, and, you know, allergies, asthma, that all started going away. And that was a consistent enough thing so that my daughter, who was seeing the same allergy practice that I had seen as a kid, and was on deck to have allergy shots like I had had and like my father had had. After my ex-wife came to the conclusion that this was something we should do for the whole family, my daughter wound up getting fired by her allergist because her allergy symptoms went away. And he commented, I've never seen anybody's allergies resolve this quickly. She came in the middle of allergy season and had no symptoms. And he was like, you don't need to see me anymore, kid. See you later.
What did she change in her diet?
Same thing. Just, seed oils. We got seed oils and wheat out of the house. And she also was having neurological symptoms. She was on deck for an ADD diagnosis. The school had proposed that. And after we fixed, the family's diet, it was amazing. Her mouth tutor. Now, if you read the literature, this is fairly typical. There's a scientist called Alessio Fasano who comments that a lot of people who have a gluten sensitivity also get an ADD diagnosis, and it goes away when they go on a gluten-free diet. So her math tutor calls us up one day and says, what changed in your daughter? She just went through 6 pages of math problems in the time it used to take her to do one, and that was pretty amazing.
Yeah.
And that was completely unprompted. She didn't know anything about what was going on. She just noticed a change in my daughter's behavior. So,
so as you have these two big things that you've noticed for both yourself, your family, how did you hone in on seed oils versus wheat as something that was your area of fascination then for the following years?
Well, seed oils wasn't my area of fascination, actually. So I basically, so there's sugars, wheat, and seed oils. I had been sugar-free for, 20 odd years at that point. So I read Gary Taubes's book, Good Calories, Bad Calories, which was really fascinating, but I didn't find the argument that sugar caused all these diseases that I had been experiencing because I wasn't eating it. The amount of sugar I ate in a year, I'll go through like an 8-ounce on a year where I'm eating a lot of sugar. I'll go through like an 8-ounce thing of maple syrup in a year, right? So I'm eating virtually no added sugars. But obviously that wasn't my problem, right? So then I started looking into the wheat thing, and clearly for me, seed oils had a huge immediate impact, but I couldn't really figure out. First I started looking into wheat because I thought that was the trigger, just because I had such a neurological reaction to it. And as I went through all the research, there just isn't evidence that that's what's causing all of the chronic diseases that we have. For certain things, it's definitely a major factor, especially for autoimmune conditions. Clearly, if you have celiac disease, it has systemic effects. Basically rots out your bones. I mean, it's pretty nasty plant if you're, but most people seem to be able to tolerate it fairly well. And then so I was still left with this question. At this point, it had become a hobby of mine, trying to figure out what was going on with this stuff. And then I discovered some of the biochemistry of what happens to seed oils in your body, and that they break down into these toxins. And that was kind of the key, because when I started looking into what the toxins do in your body, all of a sudden, linoleic acid per se doesn't do anything bad to you, right? What is bad for you are the things that it breaks down into. Those are highly toxic. And that's where you start figuring out, it's, all the things that these toxins do to your body explain, I think, all of the chronic diseases that we're suffering from.
Right. And so just for people to catch them up who haven't listened to some of the previous podcasts we've covered on this topic, you're talking about linoleic acid, which is a fatty acid here. And this is normally found in quite a lot of foods. So all fats are made up of different fatty acids, same with proteins and amino acids. And we are eating way more than we used to be eating. And this is likely the issue here. Whereas you're talking about seed oils as different from other foods, for example, because seed oils can contain up to 70+% of this in, sunflower, soybean oil, et cetera. And so we go from maybe a couple percent, single digit, of eating this one fatty acid. which even if it has toxic metabolites, your body would theoretically be able to handle, clear, deal with, and, get out of the body whenever it needs to. But when we increase that a substantial, 10, 20 fold, it's just, the dam gets full and it overflows.
That is an excellent summary. And it's important to note that, linoleic acid is the main omega-6 fat in our diets. It is a perfectly normal part of our diets. It's found in most foods that have some fat, right? I mean, even foods that are low in linoleic acid, like beef or coconut, have some, right? Our bodies, the toxins that it turns into in our body are a normal part of our body's signaling process. And our body, as you said, is adapted to dealing with these things, right? We have, everybody hears about antioxidants and how your body has this antioxidant system. Well, one of the major things that it's dealing with is the breakdown of omega-6 fats in your body. And yes, exactly as you said, what seems to be the problem is that we went from consuming X amount to, way more than that. And the hypothesis is that's what's causing us that overconsumption overwhelms your body's ability to detoxify these things. And that's what's causing the disease processes that we're seeing, whatever you want to call them, Western diseases, chronic diseases, non-communicable diseases, they're all the same things.
Yeah.
And they're all closely associated with each other, right? So if you're obese, you're more likely to be diabetic, and you're more likely to get cancer, and you're more likely to have heart disease. So it shouldn't surprise anybody looking into causation that there would be a common cause of all of these things, because they all appeared at the same time. They all appear in every single population you look at the same time. And they all appear when they start eating, what we can call the standard American diet, or the modern American diet, I prefer to call it.
I mean, I think a problem with this whole thing is that people or humans in general just have a recency bias towards what they've experienced. And most people alive now just take for granted that people die that they know from heart disease, cancer, stroke, dementia, etc. This should always, it's always been this way and it'll always be this way. So that's how it is. And
that's what, a lot of doctors tell you.
Yeah.
So, people trust their doctor, and their doctor says, oh, it's just genetic. And, as far as I'm concerned, saying it's just genetic is like saying it's God's will, right? It's just not a meaningful comment. I mean, when you start looking into, I came into this with the paleo diet lens. None of the populations that ate call it pre-industrial or pre-civilizational diet have obesity. They don't have type 2 diabetes. They don't have the high rates of heart disease that we have. And they don't have the high rates of cancer that we have. And they don't have, one of the biggest mind-boggling things that I read was there's this fascinating book published by Harvard University called Western Disease. It's Their Emergence and Prevention. And they go through autoimmunity, and they talk about autoimmune diseases in Africa. And it's a really short chapter, because they say prior to the introduction of the Western diet, they were unknown.
I think what
unknown? Wait a minute, what?
What I've heard most as an argument against this is people go, well, we're stopping, TB and infectious diseases and people dying from starvation and malnutrition, and we're just keeping people alive longer, and that's why they're dying from these, and that's why the rate is going up, because we're getting so good at extending life beyond these infectious diseases.
Yeah, and the problem with that argument is, if you look at these populations and you measure how old they get just as old as we do, right? If you look at their average lifespan, it's a lot shorter than ours is, but it's shorter because of the high mortality rate in childhood, right? So averaging a lot of zeros, you bring the average down. But the big difference between us and these more primitive populations eating a more primitive diet is that they have a longer health span than we do. They don't need glasses. They don't gain weight as they get older. Their blood pressure doesn't go up as they get older, right? So they tend to be very healthy until they drop dead of some infectious diseases at the same age that we would die.
Right.
So I mean, that's
way better. And this is the thing, like when Paul and I went to go stay with this tribe in Africa.
Saladino.
Yeah, we went to stay at the Hadza in Tanzania earlier this year just to see firsthand. I mean, you read all these reports, and this is just where I am starting to not believe anything that's written down anywhere until I see it with my own eyes. I mean, the reports of, yes, okay, Hadza are in great health. This is true. How we write in journals about why they get there is insanity. The fact that we ascribe that to a high fiber diet when we were there with them for over a week and we ate maybe 3 grams of fiber.
And they spit the fiber out.
Yeah,
I mean, if you eat a yam and
peel it and chew it, and like these things are not, they basically chew it for the water. This is what
and the glucose that's in it and the nutrients. I mean, those yams are quite nutritious. They have a lot of iodine, for instance, and it's hard to come by iodine.
Or they boil it and throw it away.
Right.
Anyway, getting carried away here. These people are healthy. We ascribe very different things to them. But like you said, there are Western diets that cause these diseases. And we see this in animals as well. It's not just for humans. Anytime we feed an animal a human diet or a Western diet or the same type of diet, the same issue happens. They die from insulin resistance. They get insanely obese. They get inflamed. This is not a human specific thing. So
when you start hearing all of these explanations for the high rates of chronic disease, you hear it's genetic. Well, that's ridiculous because it happens in every single human population and it happens in all of the animals that we feed this diet. I mean, I don't know about reptiles, but certainly birds and all species of mammals. So it's not genetic. Then you hear about, okay, well, it's probably because it's pollution. All right, well, the fattest country on earth is an island in the South Pacific. What pollution are they suffering from there? They're in probably the least polluted place on earth.
Right.
And then you hear about it's a lack of exercise. Well, okay, but if you actually measure how much people exercise, it has no correlation to weight gain or weight loss. I mean, that finding is as clear as anything in the scientific literature. Americans actually expend as much energy as the Hadza do if you adjust for body weight, which is mind-boggling, but that's what the numbers say. So all of these proposed explanations for why we've all gotten sick just fall apart pretty quickly when you start analyzing them.
And I do think it's multifactorial, and I do think there's a lot of reasons why there are contributing factors. I mean, the way I think about it is we're basically getting stabbed to death, and there are some stab wounds that are going deep into critical organs, and some that are superficial and more scratches on the surface.
Right.
And our nutrition is one that I think is going straight to the heart, and when you peel back the layers, like you said, there's a lot of different theories around, okay, so even getting people to agree, first of all, that nutrition is the primary driver and something had changed is really challenging. But if you can conceptualize that.
Despite the medical literature and the scientific literature being totally clear about that.
So that's a foundational piece that I think is like, if people can't get on board with that, I have a hard time even having a conversation with them about what to do after that.
Right.
About nutrition. But let's just assume that people do. Then we have this next layer of, okay, we all agree that nutrition is, this Western diet, quote unquote, this industrialized diet is leading to these problems. Right, now, what within that, since it varies so much, is then the stab wound that's leading to the most amount of bleeding out.
Right.
And like you said, what a lot of people I think have been coming around to, truth seekers in the nutrition space over the last 5+ years, especially thanks to your work and a bunch of other people, the sugar argument doesn't hold up as much. The carb argument doesn't really hold, the grain argument doesn't really hold up. So what ends up being left?
Well, you can look at it, again, to go back to the paleo diet perspective. If you talk to an anthropologist about the paleo diet, and I have, they will point out that we don't know what any particular Paleolithic population ate. And that's true. We traveled all over the world, and in every, if you're living in Australia, you're going to eat a different diet from people living in South America, right? But there are certain things that none of them ate, right? They didn't eat large amounts of refined carbohydrates. And we know that because of the dental records, right? Cavities didn't become a big thing until we started eating large amounts of carbohydrates. So we can look at people prior to, eating large amounts of carbohydrates, and they don't have any cavities, and they have normal teeth, and, they didn't need dentists because nobody had dental issues. Mm-hmm. So that's a totally clear path to chronic disease. That's probably the first chronic disease that you see if you go through the anthropological literature. They didn't eat huge amounts of refined sugar. They would eat honey. I mean, the Hadza eat honey. It's really interesting, actually, because the Hadza eat a lot of honey, and the Hadza have a fair amount of cavities compared to a Paleolithic person. So honey's definitely an issue. I mean, it's one of my, when I hear people say, oh, carbohydrates are part of a healthy diet. Well, okay, yes, they can be, but let's just start by defining any food that makes your face rot isn't healthy. I think that's a really low bar here, right?
And I think it's also like we found honey with a Hadza, but it is an event, and they don't eat a lot of food. So when they see it, and this is, I think, the case, we can get into this later, but why nature has made nuts so high in linoleic acid, and you and I both believe that this is leading to obesity. Like, this could make sense in a natural perspective, in an evolutionary perspective. If fall is here, winter's coming, you should put on a little bit more fat. Great. And the same thing with honey is, okay, awesome. We have this huge energy store. Let's consume it. And they ravenously tore through this hive of honey when we found it, because you don't know when your next meal is going to come.
Those, just out of curiosity, were those stingless bees or bees with stingers?
Stingless ones. And when you try to extrapolate that into, oh, I should have honey every single day because it's natural food. And I have 11 hives out on my farm, and they produce honey 2 times a year. And this year, because it rains so much in the summertime here, there's no honey to take.
Right.
And so if you're abundant every single day, year round, no matter what climate you live in.
Right. Yeah. Yeah. And that's, something, and the same thing goes for, Mike Eads wrote this fantastic post years ago called Nuts Paleo that I always point people to. And he talks about growing up on a farm and harvesting nuts. I think they were walnuts or chestnuts or something like that. And he had to use a pickup truck to ship them. He would put them in a canvas bag and run over them with his pickup truck to get them out of the nuts. It was that hard to get nutrition out of them, right? So that's seasonal. Trees drop nuts once a year, and they're tough to get. Just like, you experience stingless bees with the Hadza, but obviously most bees we encounter have stingers. And getting, there are videos of guys harvesting honey in Africa from bees that have stingers, and they get stung a lot. It's not a trivial task. But yeah, so you've got this, low intake of these things that in excess, like sugar, causes, tooth decay.
So we then feeling it back more. We have within nutrition, we agree that nutrition's causing this stuff. And within nutrition, we have a lot of naturally found in the environment foods that may be seasonal, may not be. So food availability is one huge factor. And so we should be thinking, what's the normal availability for our species? And then on top of that, it goes, okay, now let's go into the ultra refined or ultra processed foods where we're taking seeds or beans and smashing them to take out oil and then refining them. So you're talking about nuts here. Okay, we have to use a pickup truck to run over them. Right. Hey, it's like we probably shouldn't be eating a lot of those. And now we're taking things like cotton seeds, soybeans, sunflower seeds, and making those pure liquid fat.
Yeah, cottonseed is a great example. Cottonseed is toxic. It contains this fat called gossypol, which is highly toxic to people. So it was cottonseed oil was an industrial waste product of the cotton industry. And then they figured out how to detoxify it by getting rid of the gossypol. And they started off using it as an animal feed. Animals can process gossypol a bit better than people can do. But when they figured out how to detoxify it, they were like, oh, we can feed this to people and it won't kill them immediately. And we've got, barrels of this stuff from making cotton. And then they started.
It's the concept of, hey, we have this leftover industrial waste. What should we do with it? Probably feed it to humans.
Well,
that beep always just gets me.
Yeah, no, I know. It's kind of, you hear all these conspiracy theories. They're feeding us industrial waste. And well, yeah, they actually are. But you know what? They thought that they had detoxified it. They genuinely thought they had detoxified it. And in the late 1800s, they were adulterating, lard was probably the primary fat we were eating at the time, and butter. And they started adulterating lard with cottonseed oil because it was super cheap, because otherwise they were just going to throw it away. And this is, it sounds like a conspiracy theory, except for the fact that Congress had hearings and passed laws to deal with the adulteration of lard, right? And the Canadian legislature, the parliament, did an investigation into American lard and found that it was all adulterated with cottonseed oil. So, okay, let's go back to good old Gary Taubes and good calories, bad calories. He's got a great section in there looking at type 2 diabetes. And type 2 diabetes was a super rare disease in the early 1800s. And we have hospital records where they talk about how many patients they had. And it was like, gosh, I forget what the numbers were, but it was like, 70 patients over 50 years or something ridiculously small like that. Now, to put that into perspective today, 50% of Americans have type 2 diabetes, either pre-diabetes or full-on type 2 diabetes. The distinction between the two is entirely arbitrary.
Most recent report I've seen is 66%.
Yeah. Okay. So great. So how do we get from,
effectively 0%.
Effectively 0% to
rounding.
Half the population in 150 years, right?
Again,
genetic.
And it's not because we're keeping people alive more.
Yeah. And it's not because again, all of these long-lived, and I mean, there's a population called the Tucacenta in the South Pacific. Chris Kenobi talks a lot about in his presentations, which are well worth, if you want to get into the epidemiology of this, he does a really good job of that, more than I have the patience to do. But, the Tucacenta are these people who get 94% of their calories from carbohydrates. They mostly eat EMs. And the rest of their diet is pork pretty much, and fish, and, whatever else they can eat. And they're lean, they're ripped, they don't get type 2 diabetes. Their blood pressure is low for their entire lives. I don't know what their dental health looks like. That's an interesting thing. But I mean, Weston Price went around the world and looked at everybody's teeth. And, people on a traditional agricultural diet typically have like a 1% to 2% calorie rate or a cavity rate. Yeah. Which is versus 0% in a Paleolithic diet. And, so this argument, Gary Taubes' argument, I think that carbohydrates are driving this. It's tough to reconcile a population like that, or like the Japanese, who were eating 84% carbohydrates, rice mostly. and were all thin and had low rates of heart disease compared to the Americans. You know, what happened to them? Why did they change? I mean, as the Japanese have gotten fatter, they've gotten higher rates of heart disease. They've gotten higher rates of what they call the Western cancers, and their carbohydrate content went down. Their sugar part of their diet went up, and also the seed oil part of their diet went up, and the meat part went up. So, okay, you know, but the carbohydrates have gone down overall in that population. It's interesting. How do we, you know?
And so, I mean, I think that I've done a lot in the keto space and have helped try to make that easier. And it's not that, like, I don't think carbs are the initial cause of this stuff, but when your metabolism is completely ruined, it is great to remove them so that way you can function like a real human being again, because
it's the best treatment we have. Yes.
The engine's
totally
broken.
Agree.
You need a different fuel source. Great.
Right. Okay. So then why, you know, why is this happening? So why is this happening? Let's get into that. This is going to take us into the weeds a little bit. And we should probably start with one of my favorite studies that we'll just discuss. This paper by Ghosh, I think it was 2004. And they had this model where they took mice and, you know, they had this hypothesis that and I think it was a tongue-in-cheek hypothesis, but their hypothesis was that if you gave mice more polyunsaturated fats, that it would reduce their rates of apoptosis and be good for their metabolism. Okay. So they took basically two groups. They took their mice, they divided them into two groups. One of them got the control diet, which is a standard high carb, you know, some level of sugar, like 7%, something like that, lab diet. And then they added omega-6 fats to them. And what happened to the mice when they did that? They got fat, they got insulin resistant, they got leptin resistance. And leptin is a hormone that basically controls how fat you get, right? So they got resistant to leptin, which is basically a signal for you're getting too fat, stop eating. And okay, so that's a nice part of chronic disease right there. But what's really interesting is that their mitochondria started breaking down. Now, mitochondria is, you know, but I'll recap briefly for the audience, are the power plants of this cell. It's basically what allows us to go from being a single-celled organism to a multi-celled organism. That is how we combine fuel, right, fat or sugar, with oxygen to turn it into the power that we use to walk around and breathe, you know, and have an immune system and everything else that we need power for. So these poor little mice, when they gave them omega-6 fats, their mitochondria started breaking down. Then they, again, divided each one of those two groups of mice and gave them a toxin called streptozotocin, STZ. And what STZ does is it kills your beta cells. The beta cells are the part of your pancreas that makes insulin. So effectively what they did is they made them diabetic. It's type 1 diabetes, essentially, which gives them hyperglycemia. And the hyperglycemia caused their mitochondria to collapse. That's not a good thing. And it gave them, back to the original hypothesis of this paper, right, that seed oils would be good for apoptosis. It did indeed reduce the rates of apoptosis in these mice, but it did it. Apoptosis is a controlled pattern of cell death, right? So when a cell becomes dysfunctional, the body basically says, okay, you've got to kill yourself and we're going to cart you off and, you know, reuse your components to build new cells. Perfectly normal part of our body, right? That's why lots of people are fans of fasting, because fasting kind of upregulates apoptosis, and it's kind of like a garbage cleaning system. You get broken cells and, you know, you clear them out. cancer is a problem of dysfunctional apoptosis in part, right? So this is an important process. So sure enough, the apoptosis rates in these mice went down, except they got necrosis instead. Necrosis is an uncontrolled cell death, basically where instead of saying, hey, I'm broken, take me away, it just, the analogy I like to use is it's like a guy at the bar who's had too much to drink. Apoptosis is the guy says, I need a car to take me home, I've had too much to drink. Necrosis is the guy gets into a fight at the bar and then throws up all over the place, right? So these mice got necrosis and they got heart failure and they got necrotic lesions in their heart failure. Well, it just so happens that that's another epidemic that we have in the United States is heart failure. My father died of this last year. And basically what happens is your heart starts breaking down. So here we have this model where mice are fine on carbohydrates, seed oils make them super sick. Hyperglycemia causes this accelerated pathway of necrotic cell damage and, heart failure. Oops, there we go. Nice little model. And it explains why, it basically explains, I think, all of these chronic diseases, the late stages, are typified by two things, necrosis and fibrosis, right? And here we have a model that induces necrosis and fibrosis. If you go through the literature, right? The other thing my father had was atrial fibrillation. That's basically what happens is your muscles, the composition of the muscle in the heart changes and it can't beat correctly anymore. And you've got all this, these fibers, I don't quite know how to describe this easily, but you see the same thing in advanced liver disease. You have this dysregulation of the body's, your body has this thing called the extracellular matrix, which is, we know as the cartilage, the tendons, the ligaments, right? But it goes throughout your entire body. It holds all your cells together. And that's, it's what holds your bones together ultimately. That is constantly being rebuilt. So what happens is you get this dysregulation of this reconstruction process. And instead of rebuilding proper extracellular matrix, you get this fibrotic phenotype where muscles can't work correctly, your tendons and your ligaments start breaking down. And here we have a demonstration of how to induce that process, using common food items.
What were the actual sources of the food? Soybean oil?
Yeah, I forget which. They only used, the problem with this study was they didn't have a fat control. It would have been nice to see if they'd used some other fat, but they were just kind of making the point. Reading between the lines in this paper, it's pretty clear that they knew what was going to happen. And this was just a demonstration that, seed oils aren't healthy and hyperglycemia on top of seed oils is super bad for you. Right. Which gets us back to the 50% of Americans who are now type 2 diabetic, because that's essentially where they're at.
Yeah. And so, okay, here we have this being brought in and obviously causing all these problems.
Right.
In a mice model. I know a lot of people were going to argue with that, but this is just an initial sort of like, okay, this is pointing the finger, at least in a general direction here.
Right. So yeah, so that gets us to epidemiology. If you look at the studies that are generally published and that people who disagree with this hypothesis point to, they all have one thing in common. Right? They are all looking at people in industrial countries. That's where epidemiology generally gets done. If you look at the bigger picture, there is no population that I'm aware of that is a quote unquote primitive population that eats industrial seed oils, right? They can't. Seed oils are hard. If you ever see a seed oil manufacturing facility, it looks like an oil refinery. And that's basically what it, like a gasoline refinery. And that's basically what it is. every single population that we see now, there is one exception to that, and we'll get to that in a minute. Every single one of these populations, as Weston Price put it, back in the 1930s, that starts eating a Western diet, which he defined as canned foods, refined flour, and vegetable fats, get sick, and they all get the same diseases, right? There are no exceptions I'm aware of to that. And then, is there a population that eats a Western diet that doesn't get these diseases? No, there are no exceptions to that. Now, the exception to the ancestral populations, the quote unquote primitive populations, turns out to be the Bushmen in Africa. They are a different group from the Hadza. They're called the, that's it, right? How did you say that?
Kung Song, I think it's
Kung Song, yes. And they've got a little, you're supposed to make this clicking sound in there somewhere.
Or the cat.
Yeah, exactly. So we'll call them the Bushmen. So what did the Bushmen eat? They, were hunter-gatherers. They didn't have any agriculture, but they ate a lot of these things called Mangongo nuts, which is another seasonal food. And Mangongo nuts.
They apparently eat a lot of these things, and they're very plentiful with where their camps are. And I think a lot of this is another misconception, that people think that these tribes are purely nomadic, when the reality is they actually have maybe 10, 20, 50 camps that they circulate between. Because if you are stumbling around in the wilderness and you find some areas with more resources, you go there, deplete them to a certain degree, move on, come again in a year, 2 years, 3 years, couple months, whatever it may be, and the resources are back and replenished. So this is the model.
And there's a seasonal component, because the animals are moving around seasonally based on the wet season and the dry season, and plants are coming into fruit during various parts of the year.
But generally, they're going in between areas that they already have established for a very long period of time, and not roaming around and definitely hoping they'll stumble upon food
randomly.
Yeah. And so they actually, the Bushmen concentrate around these high production areas of Mangongo nuts because they're so calorically dense and really easy to get comparatively to hunting.
Right. And they get a lot of I've seen people saying they're getting, 30+% of their calories from these Mangongo nuts. Well, turns out the Mangongo nuts are pretty high in linoleic acid. I think the fat's like 2/3. I'll have to go, don't hold me to that number, but they're pretty high in linoleic acid, like most nuts. And they eat a lot of these. And so it turns out that somebody gave them a oral glucose tolerance test, and they failed. So that's the only hunter-gatherer population I'm aware of that has ever failed a glucose tolerance test. And they just so happen to be the ones who eat an enormous amount of seed oils in their diet by their consumption of these Mangongo nuts. That's interesting.
Right.
When they moved out of the, most of these hunter-gatherer populations are losing the ability to be hunter-gatherers, and they're picking up a, more agricultural diet. And when they did that, they became able to pass a glucose tolerance test. Lots of caveats around that observation. That test was done a couple of times. The first time it was done in that population, they did it right in the middle of Mangongo nut season. Another guy did it and they passed, but he didn't say what time of the year he did it, so we don't know.
Yeah, I just pulled up a paper, by the way, and percentage of fat in a Mangongo nut is 40% linoleic acid.
Right. Okay. So they're getting a fair bit, and they're showing signs of diabetes.
Yeah. And so
that's our one, looking at the big picture epidemiology, we have one group that shows signs of chronic disease, and they just so happen to be the ones who are eating a lot of these omega-6 rich nuts.
And so with these foods, with these seed oils, things like that, you're isolating this fatty acid called linoleic acid. From your research, is this, a certain percentage of the culprit of high omega-6 fats, or is it just pretty much the only one that we should be concerned about? This is where I sort of, or is that just all we've looked at with a tunnel vision now? Are there more things in these compounds, in these seed oils and the nuts, et cetera, that are adding on and piling on as well?
Well, so the two main omega-6 fats are arachidonic acid and linoleic acid. Your body converts linoleic acid to arachidonic acid. It's a very small amount. Things like you don't get much arachidonic acid in your diet because, cattle make it like we do, but it's, again, not a large amount of the diet, right? Whereas linoleic acid, if you're eating an industrial diet and you're refining, or I guess if you're the bushman and you're eating a ton of these nuts, you're concentrating it, right? I mean, that's the whole point of what you're doing. If you're in India 2,500 years ago, when diabetes was first discovered, they were crushing sesame seeds to get sesame seed oil, right? That was a significant food source for them. Interestingly enough, also when diabetes was first described. So that seems to be, so why are we interested in that particular fat? They are very susceptible to oxidative damage, right? I mean, we all know, we've all heard the term rancid, right? So a rancid fat is a fat that has been oxidatively damaged. We don't eat rancid fish. It smells horrible, right? We don't have the same reaction to omega-6 fats going rancid. It doesn't smell like, a fish that's gone bad does to us. So we can eat these fats.
We can eat them. We just don't have the evolutionary filtering process, knowing that these are bad for us. I mean, I think in big part, this is why seed oils are so dangerous, is because we have changed the thing from the natural state of the food to something so completely just
quantity.
Yeah, quantity. Right. And we, using the refining, bleaching, deodorizing, all this type of stuff in these oils, even when they go rancid, we've taken out any sort of thing that we could be using from our natural senses, be it sight, oh, that looks disgusting, I shouldn't drink or eat that.
Right.
Smell, taste, all of these things, all the senses that have protected us from an evolutionary perspective from bad quality food that's not good for us.
Right.
Thrown out.
Right. And most of these, not most of them, but some of them do contain omega-3 fats, seed oils, and they take them out because
they oxidize so much and smell like fish.
Bingo. And then people don't want to eat it. So, I mean, you can just imagine if you made potato chips in fish oil and then stuck them in a bag and put them on the shelf in the supermarket for 6 months, what would it smell like?
Right. Yeah. And is this right? That the majority of the rotten smell in fish is just the oxidized omega-3?
Yeah, that literally is what the smell is oxidized omega-3. Right. So yeah, they take it out because it ruins the shelf life for these products. And rancid omega-6 fats, some people actually find them slightly pleasant. And there's an evolutionary explanation for that, right? Because when you cook food, if you cook meat, you're oxidizing these fats and it gives it a certain flavor. And humans have adapted to be dependent on cooked foods. We can't survive on a raw diet anymore. So it's not too surprising that we would say, oh, these, delicate. So omega-6 and omega-3 fats are both what they call polyunsaturated fats, which means they have missing hydrogen atoms. A saturated fat looks like a little ladder, basically, with carbon atoms down the middle and then hydrogen atoms down the side. They call it saturated because it has a full complement of hydrogen. If you take one away, you get a monounsaturated fat. That's oleic acid, the fat that we find in olive oil. If you take two or more hydrogens away, you get polyunsaturated, and those are very susceptible to oxidative damage.
The ladder analogy with stability, man, that's good. I haven't heard about that before. I mean, if you're taking it to support between the rungs multiple times on a ladder, good luck climbing it.
Yeah, right. And they, it gives them different properties which are useful in your body. I mean, all these fats are things that we're supposed to be eating. Just, but anyway, when you take that hydrogen out, then it makes it very easy for oxygen to get in and damage the fat, right? And it breaks it down into these byproducts. The most studied is this thing called 4-hydroxy-2-nonanol, which is basically half of a linoleic acid molecule. And this is the one that's the most studied, and this is the one that really has caused people to realize, these fats are a problem in our diet, right?
So with the amount of literature on 4-HNE, this is one of the things that continues to shock me from people saying that this isn't a problem. It's very clear that one thing leads to another. Is there any, I mean, I guess you'd be the expert here. Is there any other source? Like, can you get 4-HNE from any other food source or any other way in the body that converts?
Well, that's the great thing about it in determining causation, because it is only made from oxidized omega-6 fats.
You literally have to, and we don't make these in our bodies.
We do make them in our bodies. That's an important point. But in small amounts, and it's basically a danger signal, right? So,
but it's through arachidonic acid, right? Is it, or
from linoleic acid or arachidonic acid? And quantitatively, because there's, especially in a modern person, there's so much more linoleic acid in your body than arachidonic acid, that the vast amount of HNE that's produced is coming from linoleic acid.
But you're talking about the formation of HNE, not the formation of linoleic acid in the body?
Yeah, we can't make linoleic acid in the body. That's another nice thing about it in trying to determine the pathway of causation. You can't make linoleic acid in your body. You have to consume it, right? And then this toxin is only made from linoleic acid and arachidonic acid, the bulk of which are made from linoleic acid. The bulk of the arachidonic acid is made from linoleic acid that you are consuming.
So we have this very well-studied toxic metabolite, 4-HNE, and many others as well. This is just one that you say that there's enough of mechanism to put the puzzle together. You have a lot of other ones as well. And it comes from primarily linoleic acid, arachidonic acid, and we get all this in our diet, and the amount has been going up drastically. And all of this ties to, like, this is just where I get a little frustrated, and I know you've been living in the weeds for a very long period of time. We tried, what I've tried to do in this episode here is give people sort of the roots, the trunk, build this tree of common sense around this topic and how to think about it. And yes, it helps to learn all about every pathway, all the epidemiology, and like really dive in to build up these layers of knowledge to be able to hang the trunks and the branches and the leaves. So you build this tree of knowledge. But when you start building it up and having these, these assumptions that are tested and verified, and okay, we can say with pretty good evidence that, again, nutrition is a huge part here, and that within nutrition, that the seed oils are a big part, and then within the seed oils, we have this linoleic acid, this omega-6 fatty acid, and then within that, we have this. And I don't know where people get lost. And I think there's a lot of different ways that I think we'll have to dive into a part 2 around some of the common claims against what you're talking about here. But I think this has been a good little chat to elucidate some of these common claims to get people.
Let's just quickly say where people get lost, right? This is not, if we're claiming that excess seed oils are toxic, they're not acutely toxic, right? It's not like you're eating cyanide, which will kill you promptly, right? This is something that is having a small negative effect, right? And the analogy I always like to use is cigarettes. You don't get lung cancer from one cigarette. You don't get lung cancer from a pack of cigarettes. Unless you've got really bad luck, you don't get lung cancer from smoking 2 packs a day for a year, right? You get lung cancer from smoking for 20 years. And I think this is on the order of that kind of problem.
Yeah. And I think it's actually even worse, because at least with smoking, there are some feedback loops. They said we've sort of
immediately disgusting. Yes.
Immediately disgusting. Smells bad. A lot of times it can make people cough, especially if you've never smoked before or have smoked for a long period of time. And so after there's some amount of feedback loop. And unless it's someone like you who are in a very ill spot and have their symptoms subjectively dialed in so tightly where you go, oh, this thing I removed leads to that. Even when we're talking about sugar and wheat and things like that, I think a lot of people can tell a difference. I mean, again, it's still with sugar, people can get a crash within 90 minutes and still go their whole life and not know that they're eating too much refined sugar and that it's affecting their blood sugar and mood and balance. So even 90 minutes for most people is too long of a feedback loop. And now we're talking about creating a food that is odorless, tasteless, and sticking it in literally everything that we eat that has a feedback loop of decades.
Right.
And so how could it be bad? You know, like you said, like I think that people's bias goes shorter and shorter and shorter to, oh, what is the appropriate feedback here? Like, are we getting feedback? And this is what makes studying things so hard.
Right. And it's also, you know, when you start looking at these epidemiology studies, you know, imagine if you're trying to determine what causes lung cancer and everybody you study is a smoker, right? I mean, that's epidemiology 101 of what not to do, right? I mean, that was Weston Price's great insight when he was trying to figure out why people were getting cavities. He went and looked at people who weren't getting cavities and looked at the difference between the two. It's not rocket science, right? Yeah, but when you look at most epidemiology, they don't do that. They look at only sick people in industrial countries. In the case of seed oils, who've been eating this stuff for 100 to 150 years.
Yeah, I mean, so the fear that I have, and this is why Paul and I wanted to go see the Hadza as well, just to experience that, is that in 50 to 100 years, we're not going to have any of these populations left to study.
Probably less than that, unfortunately.
And there's going to be no baseline left.
Right.
And I mean, the problem is when you bioaccumulate these fatty acids, which happens. So if you eat them, the saturation in your body goes up and up and up, and either the phospholipid membrane, nervous tissue, your actual adipose tissue, and your stored triglycerides, you start carrying more and more and more of these. So even if you take a population and split them into two, and then try to study them and their effects, well, if you have all of this stored linoleic acid or you know, omega-6 fatty acids in your body, like, what is the impact of that as they get released while you're trying to study?
Right. And, you know, sadly, the answer is that gets back to one of the real issues, you know, when you go through the scientific literature trying to look at the effects that these fats have, the negative effects start at a very low intake, right? Because in a natural diet, you're not getting a lot of these fats. And in the animal models, you know, the cancer models is where they've done it the best. There's a couple different cancer models where you can't induce cancer in a lab animal unless you're giving it some amount of linoleic acid. And typically the amount of tumors that you can induce goes up until from 2 to 10% of the diet becomes linoleic acid. So like the breast cancer model, tumors go up until 4% of the diet, and then it flatlines. And in pancreatic cancer, it goes up to 4%, then it actually goes down a little bit afterwards. You still get a high tumor rate, but there's like this peak at 4%. Americans eat 5 to 10 up to 20% of our calories from linoleic acid, and we've bioaccumulated it in our adipose tissue over our lives. We know this happens. I mean, this, you know, Stefan Guillenet actually wrote the paper that showed that we bioaccumulate linoleic acid, and that the composition of our bodies as linoleic acid has gone up consistently over the last, you know, 100 years.
Yeah. One thing I'm curious about,
and yeah, so if you're trying to figure out this teeny little amount of fat can cause a problem, and everybody's way over that, and those are all the people you're looking at, you know, you can't do any valid science that way. You have to go look at the people who don't eat it.
It was some of the stuff that I've seen myself is, okay, this can stay in phospholipid membranes for, up to 2 years. Kate Shanahan, her thought is 5 years until you can get some of this stuff out of your body if you stop eating as much of it. Like, what have you seen as far as, okay, if we freak everybody out about this compound and they try to figure out some no fat diet, even where if it's possible, it's not. But even if they limit to red meat only, couple single digit percentage of linoleic acid, like how long does it take to get this stuff to a normal level in your body again? Do you have any sort of assumption there?
Yeah, it varies by membrane, right? So tissues with a high turnover rate, like your skin, it's going to turn over very quickly, right? Kate's number of 5 years comes from the half-life of linoleic acid in fat, which is, I think it's like 9 to 11 months. So meaning in 9 to 11 months, half the fat in your fat cell goes away and is oxidized. So if you do the math there, that means you get down to an evolutionary level in 4 or 5 years, right? Cartilage is probably the tissue with the longest half-life. And I've seen numbers of 15 to 100 years of the half-life from cartilage.
Oh,
so that, is problematic.
I mean, for people who don't understand the issues of that, I mean, the majority of the issue, so when my old career being a chiro, obviously joint pain is a huge part of the practice, and most joint pain actually comes from articulation of the joint, with the joint surfaces becoming irregular and rubbing on each other, creating localized inflammation. And
Right.
so we're talking about joint surfaces, which are made of the cartilage, these soft tissues that are supposed to protect the end caps of the bones. When those start degrading is when you actually get pain in joints that lasts for a long period of time. It doesn't mean that you have to experience pain if you have joint degradation. But for example, even if you take an MRI of somebody's spine, for example, with whatever decade of life you're in, this is the average for Americans of like percentage of people who have complete disc degeneration. So if you're, for example, 50 years old, you have roughly 60%, you see in the 6th decade of your life, you have roughly 60% of the population has severe disc degeneration, if not disc herniations.
That's not, I hadn't heard that. That's not good.
It's not good at all. But I mean, the question,
the example,
I've never even thought about this before, but if you're talking about the half-life of that tissue being 15 to 100 years, and you're talking about the increase in rate of this, I mean, that with Hadza, for just to use them as an example again, because I was with them, they sit in a full squat all day, every day. I was started to do some like joint testing with them. These people have phenomenal joint capacity. From what I gleaned and what I could translate, zero physical pain unless it's from acute trauma, falling off of a rock climb or tripping on something, whatever.
Right.
And I'm just like, how much of this is actually leading to joint degeneration and joint pain?
Right. And one of the, again, we've got a couple of these canary conditions, type 2 diabetes is obviously one of them. Heart disease is obviously one of them. ACL tears. The ACL tear incidence is going up, right? It's an incredibly common injury. I, have looked into this in the past, but I can't really remember off the top of my head what the number is. I think it's like, several 100,000 people a year in the United States get ACL tears. It was unknown to medicine prior to the 1960s.
Yeah, I mean, I think that also the prevalence of non-contact ACL tears. Well, those should never happen. I understand, like, okay, when you're talking about contact sports, and you have
and it was first described in the football team at West Point, right? That's a contact ACL injury. My friend's girlfriend jumped across a stream the other day and tore her ACL and her MCL, and is going to go in for surgery. That would never happen in a Hadza. That would never have happened in an American prior to recent decades.
I mean, the Cairo bias in me says there's probably a very large contribution of how we're spending our time and having our joints and tissues in certain positions, like the flex knee in a seated position and the relative lack of, okay, maybe we're, like you said before, we are moving just as much as the Hadza from a caloric expenditure, but we're sitting in a chair 95% of the day, and then we go bust our asses in a CrossFit gym or go run a marathon, and you're taking a door that's hung on a hinge improperly and going 15,000 times on a creaky hinge. Like, of course, we're going to have some problems here, but also like the composition of the tissues. If like you have that plus poor composition of the tissues, that's a recipe for explosion in the knee.
Yeah, I mean, obviously your cartilage is designed to be that hinge for, 100 years or whatever your life expectancy is supposed to be. Kids shouldn't be getting ACL tears. Right. I mean, kids by their nature, although we're trying to mess kids up too. I've got this sun shining in. So let's look. How do we treat cartilage diseases? We use COX inhibitors, right? Aspirin, what they do is they treat the pain, but they don't actually solve the problem of the tissue breakdown, right? What does a COX-2 inhibitor do? It inhibits the metabolization of omega-6 fats in the body. Okay. Right? So we've got this chronic pain condition that we treat by inhibiting the breakdown of omega-6 fats. What unfortunately COX-2 inhibitors don't do, they prevent arachidonic acid from becoming these pain mediators, right? So they make you feel better. But what they don't do is prevent omega-6 fats in the tissues from breaking down into these toxins, right? So HNE, which is, I mean, I feel bad about going on and on about this thing, but it does seem to be the common mechanism, causes the cartilage breakdown and it causes the fibrosis. I mean, you can find there's a paper out there that explains that HNE is the cause of tissue fibrosis, period, full stop, right? And that seems to be what's happening in our cartilage. God, there's a ton of papers out there looking at this process, and you see protein damage caused by HNE in the cartilage. HNE alone causes inflammation. It's what they call a pathogen-associated molecular pattern. So your body sees it as basically a bacterial signal and attacks it. So what do we see in, arthritis? We see it's got components of an autoimmune disease, like every single one of these other chronic diseases. Your macrophages, the white blood cells that are supposed to clear out pathogens, are attacking your own body. They're attacking your cartilage, right? And they're attacking your cartilage because they're getting this signal from omega-6 fats breaking down that you have an infection, except it's you. It's not the infection. I don't know. Should we pursue this or? Yeah.
So I guess, I think that this episode is great, again, to help people build a trunk of knowledge. So that way, I'd love to get you on for another part 2 to dive into some of these more complex things soon. But I guess to sort of round off how people should be thinking about these things, again, like we're saying that these diseases are not normal. The precedence is staggering and increasing rapidly. Obesity, diabetes, et cetera. It's from nutrition. We can clearly see this. And nutrition, it's these seed oils. The seed oils lead to these, or I guess more than just seed oils. So I guess that's a good point to pause. And we think about the most prevalent in pervasive contributions to our diet being these seed oils. However, what else do you see as a problem of where the Western diet is consuming high amounts of these omega-6 fatty acids, linoleic acid, et cetera? So we have the seed oils as an obvious number one, just from I think it's like something like 25 to 30% of our calories in the US at least This is a study, I think, by the FDA or the USDA. It's coming from quote unquote plant fats, which is, you know, what these seed oils are. And then we also have what I think is a problem that's not talked about, is that we feed all of our animals, even the pasture raised animals. So getting into farming and trying to figure out what I want to feed chickens, pigs, et cetera, on my property, there is no example that I'm aware of any pigs or chickens at any level being raised on anything commercially other than corn and soy.
Yeah. There are some, even the ones where they are pasture raising them, they get some level of supplement from grain, which I don't think is necessarily a problem.
It's still free choice. And even what I've seen from, is I've been asking a lot of farms to either do testing or have done testing on them. And some of them are actually way higher in linoleic acid. I'm not going to name anybody right now, but way higher in linoleic acid than Smithfield commercially raised pork, which is like a giant CAFO raised pork production, 30-40% in pork I've seen in some of these pastured pigs. And
okay, well, that's a whole nother topic.
Yeah,
so let that one go for now.
This happens in monogastric animals because we don't have the ability to break down the fats. So what happens in ruminant animals, we break down to these 2 carbon chains, they build them back up, and they basically make saturated fats out of anything, you know, even if it's grain or if it's grass or whatever. It's pretty magical little thing that they have going on in their guts. We're talking more about pork and chicken here, which, as the demonization of saturated fat and red meat for a variety of reasons continues to go on, we're eating an enormous amount now, especially of chicken, which is even higher than pork in most cases. And so we're getting a lot of linoleic acid from these sources as well. Do you think that sources like this are as bad as a seed oil, for example?
Well, I'll tell you, there's Siobhan Huggins, who works with Dave Feldman, who's done a lot of cholesterol research. She was on a carnivore diet, and the best indicator we have right now of heart disease risk is something called Lp(a), and she had a very high Lp(a) level that she thought was genetic. So we talked on Twitter, and I told her that it's probably because of her pork diet, because it was high in linoleic acid, safe bet, because she was just eating supermarket pork. So she switched from supermarket pork. Now, if you go ask a doctor, Sam Zemeckis, who's, you know, Dr. LPA Doc on Twitter, I think, go ask him. He will tell you this is genetic, and that there are some ways you can kind of tweak it a little bit with diet, but this is supposed to be a genetic thing. Okay.
Why does he even have a job then?
Huh?
Why does he even have a job if that's if everything's set in stone, it's just genetic? I guess.
Yeah. Well, that's you know, that's a whole nother topic. But at any rate,
okay.
So she decided to switch her carnivore diet from pork to beef. Her LP(a) level got cut in half. So much for that genetic marker. And what is Lp(a)? Well, Lp(a) is a mechanism in the body. It's a protein that attaches to an LDL molecule, and its job is to go sweep up and dispose of oxidized linoleic acid. That's what it does.
Of course.
So lo and behold, you cut your linoleic acid intake, less of it gets oxidized, and your Lp(a) problem is just cut in half. Boom, like that.
So we see in the case of Ms. Huggins here that there's a reduction in that. So N of 1, obviously. However, I mean, it's like we were talking about earlier. There's,
but it's an N of 1, yes. But there's a
clear
ton of evidence that dietary intake of linoleic acid controls the composition of LDL. I mean, it's indisputable that that's the case, and it's indisputable. I mean, I stopped counting the papers that I found that show that. And I stopped counting the papers that I found that show that LDL composition predisposes them to oxidation, right? And an Lp(a) is a type of oxidized LDL, right? And the marker for an oxidized LDL is oxidized linoleic acid, period, full stop.
So to not overcomplicate things for people who are listening, trying to figure out what the hell they should eat, this is more...
Well, yeah, so when your linoleic acid content goes up, you become more susceptible to oxidative damage from carbohydrates, from hyperglycemia, right? And from fructose. So that's why my hashtag on Twitter is low carb, low 6, because when you have a high amount of linoleic acid in your body, you become more susceptible to damage from those two things, right? From refined carbohydrates and refined sugars. Theoretically, if you get your linoleic acid level back down to an evolutionarily appropriate level, you should be able to eat those things. But, you know, as we discussed, that takes a while.
Right. Yeah. So again, we're talking about before we have the availability of food as a thing. So if we eat walnuts in the fall, we might expect to get a little bit fat. We probably shouldn't be eating them all the time. And then we're talking about an unnatural amount of this via the seed oils we'd never be able to get that. I think that meat actually falls into that unnatural amount. Same thing where, again, if we weren't feeding these animals corn and soy, I mean, I have a couple of papers that show both chicken in pigs, I think in the Tokelau, were down in the single digits for linoleic acid. So we have at least some markers of what the animals should be looking like.
Right.
So yeah, having this it's really confusing. And I don't think anyone's really put this into a really great, coherent explanation of here's exactly how all these foods are adulterated, and probably are higher than what they should be. Here's what you should be eating if you're at this certain thing. But other than, I guess, the animal products, pork, chicken, the seed oils, what are some other, nuts, seeds in general? What are some other sources that people are probably getting in their diet that are not appropriate for our current level of linoleic acid?
Well, salad dressings are a big problem. They're all made with soybean oil pretty much nowadays. And that means mayonnaise. Some people call it salad dressing. Mayonnaise is an issue. But yeah, it's basically anything that's made with the seed oil and anything that's fed seed oils. So you can take salmon and feed it soybean, which they do.
8x the amount of linoleic acid or something I've seen, or more. And
it will make, if you feed that salmon to a mouse, it will make the mouse sick, right? So we're the exact same thing. So yeah, cut back your direct seed oil intake. That means fried foods. Cut back your intake of animals that have concentrated linoleic acid in their tissue, like chicken and pork. Focus on ruminants. Lamb's great. I mean, most lamb's grass-fed. Beef is, even grain-finished beef doesn't have much linoleic acid in the body. Pastured beef is very expensive. Not everybody can afford to eat it all the time. And it's not necessary, I don't think, because the difference between the two is very tiny. Eat some fish to get some omega-3 fats. Don't take fish oil supplements. You want it in the natural form that's in the fish, not what you get in the pill. That's another whole topic, but
So these are where people are getting this stuff. So all these sources, and then to finish out this tree, we have all these downstream effects of, linoleic. We get these high amounts in our diet, linoleic acid, then they go in the body, and they terrorize your body. Not necessarily directly, but more so with all of these downstream metabolites, 4-HNE being one of them, among many others.
Right.
So I think that will allow us to have a nice scaffolding for the part 2, where we start diving in and explaining what I want to go through. Which is what I wanted to do in this conversation was chat about the general, like, when I'm starting to post more about this stuff as well publicly. You've obviously been doing it for a very long period of time. But there's a lot of pushback, and there's sort of these common themes of how people say, oh, no, it's actually not a problem because X, Y, or Z. And so I kind of want to go through that in a very objective way and talk about why those are maybe not grounded in reality. And would love to do that part 2. Another quick question to just tie into the food stuff, because it's just something that I've been thinking about for a while, that I've been waiting to ask you about, what natural food sources like nuts, even egg yolks and eggs. I had this paper from, I don't know if you've seen it, from Sakanaka, I think in 2004, about hydrosylates in eggs blocking the oxidation of the polyunsaturated fatty acids. And so it seems like there's like
I haven't seen that.
some mechanisms that might be interesting for whole foods like that. And I've heard about similar things in nuts. I can send it your way. You can peep through it. But yeah, I wonder how much people should be worrying about this. In like, should the goal be every single food we look at from a gas chromatography spectrum and say it should need to be low in the linoleic acid? Like, I think that whenever we get ultra reductionist here, that we end up sort of going a little too far. And so that's why I like having some sort of ways to think about this.
Zero's not the goal here. Personally, I've never had an omega-3 test. I don't do any blood tests. I don't test my food. I try and do the best that I can. I mean, I buy pastured eggs, to the extent that I can get them. And I avoid chicken and pork and obviously concentrated sources of seed oils. I mean, once in a while I'll be bad and I'll have some potato chips or some French fries or whatever and suffer the consequences, which, for me are pretty consistent. So I don't eat them all that often, because when you have but not everybody has the reactions that I do. It makes it a lot easier for me to be, but I don't, you don't need to be at zero on this.
Right.
And it's not possible to be at zero. So you shouldn't try to be at zero, right? These are natural fats. They're a natural part of all whole foods. And what you're trying to do is get an appropriate level of them, and then do other things that are going to make your body more resilient against whatever level you're eating, like, aerobic exercise is protective. So try and do both sides. Everybody agrees ultra processed foods are bad for you, right? This is pretty much the definition.
Not everyone.
Really?
I got a lot of if it fits your macros bros online.
Oh God.
Saying that this is not the case, and it's calories in, calories out, and your body can handle whatever it throws at it. It's actually something that I ranted about the other day quite a lot on Instagram.
Well, I mean, I've started to refer to those folks as the flat earth crowd, because the scientific evidence is so overwhelming that that's not the case. I mean, your macros don't really matter. I think they're right to the extent that if you're eating a healthy diet and you're a healthy human, no, your macros don't matter. But, that's 12% of Americans at this point.
Yeah, I think this is generous. Yeah. All right. Let's wrap here and then go deep into round 2, hopefully soon. And then we'll release this as a 2-part series if you're cool with that. Until then.
Yeah, it'd be great. This has been a really awesome conversation. You're asking all the right questions. You obviously have done a lot of research on this.
Thank you. A lot of it comes from you. So if people want to read up and prepare before the next episode, before they listen to the next one, I think that your website is an overwhelming but thorough place to start. So if you want to just tell people where to find that, as well as any of your other work.
It's yelling-stop.blogspot.com.
You need new URL, Tucker.
Yes, I know. I've been told. And probably a new blog, because it's horrible. But it's got a lot of really interesting information on it. And then I'm pretty active on Twitter at Tucker Goodrich.
All right, Tucker, appreciate it. We will chat soon, and really appreciate your time today.
Thank you, sir.